Hello my dear students, welcome to Mathswell YouTube channel, a virtual platform for mathematics. So today we are going to solve some more examples on the linear equation one variable which we have seen in the last video. Today's subtopic is the solution of linear equation in one variable in the case when the variable is on both sides. That variable will be on LHS as well as RHS on of the given linear equation. And also we'll see the example on the applications of this type of equations. Okay, so let's continue with the example on this. So what will be the nature of the equation in this case will be the equation will be of this type. So here if you see the equation 3x equal to 2x plus 18, right? So here the variable is x and it is on both sides, the LHS as well as the RHS, right? So here we have 3x equal to 2x plus 18. We need to find the value of x. Solving the linear equation is nothing but the finding the value of the variable, that is x, in the given linear equation in which the variables are on both sides. So in the case when the variables are on both sides, we need to convert, or we need to take or keep both of the terms of variable to the same side. So here in general we change the side of that variable having the lower coefficient. So here if we see, the for one term is 3x which is to the left side, other term of the variable is 2x which has the lower coefficient. So we need to change the side of this 2x, means we need to do the transposition. We transpose this 2x to the LHS, right, with 3x with the higher coefficient. So here we have, so when we change the side of any term, the sign will also change. In case of transposition, when we transpose any term from one side to other, the sign will definitely change. So here 2x will become minus 2x. So we have the left side with the two terms having the variable. So this 3x minus 2x, we kept or we brought both the terms of variable to the one side and constant to the other side. So here we have 3x minus 2x. So the difference of two variable terms x, it can be done by taking the difference of the coefficients. So here the coefficients are 3 and 2. So 3 minus 2 will be 1. So it is 1x. So either you can write 1x or only writing x will also be sufficient. So 3x minus 2x will be 1x or only x, and which gives us the value of x, which is nothing but the 18, which is constant to the right side. So that only will be the required solution for the given linear equation in one variable having the constant or having the variable on both sides. So isn't it easy example? Yes. So this type of example only will ask in the exam to solve the linear equation in one variable. So first we need to check the sum and the variable terms, whether they are on the same side or one side or on the both sides. Clear? So in this way we can solve such type of example. We'll solve more examples. Let us see this next one. 4z plus 3 is equal to 6 plus 2z. So what is a variable in this example? The example has a variable z. Z is nothing but the variable. So any alphabet will be the variable in the example. Okay. So z will be the variable here and it is on both sides. This term of z is on both sides, LHS as well as RHS, left side as well as right side. So 4z plus 3 equal to 6 plus 2z. So if you see here, the term with z or the term of z to the left side will have its coefficient as 4, whereas to the right side will have the coefficient 2, right? So 2z will be a variable term having the lower coefficient. So 4 is greater than 2, means 2 is the lower coefficient term, so which can be taken to the left side by using the transposition. Okay, so transposing this 2z to the left side, so obviously the sign will change. So we have 4z minus 2z This 3 remain as it is equal to 6. Now we transpose the constant from the left side to the right side, because we need to keep only the variable terms to the left side and constant to the right side. So taking this 3 again to the right side, means transposing 3 to the right side, will gives us, so since 3 is positive, so this positive 3 will become negative 3, that is plus 3 will become minus 3 if we take it to the right side. So 6 minus 3. So 4z minus 2z, again taking the coefficient of the coefficient, taking the difference of the coefficient 4 and 2. So 4 minus 2 will be 2, and the right side is 6 minus 3. So 6 minus 3 will become 3. So simply the difference of two natural numbers. 6 minus 3 will give us 3. 4z minus 2z is 2z. So 2z equal to 3. We have one more equation again, linear equation in one variable with the variable on one side, that is z is to the left side. But to get the solution of this equation, we need to remove the coefficient also. We need to write the variable free from its coefficient. Okay, its coefficient will be only 1. If it's have the coefficient other than 1, we need to remove it. So to remove the coefficient of a variable or any term, we need to divide by the same number. So here the coefficient of z is 2. So we need to divide by 2 on both sides. So dividing by both sides will gives us, what it gives us? It gives us 2z upon 2. So this 2 will get cancelled, and the right side 3 is also divided by 2. So it will gives us the value of z equal to 3 by 2. Or we can say z equal to 3 by 2 is the solution of given linear equation in which the variable is on both sides. So this is the way to solve such type of linear equation in two variable having variable on both sides, right? So the previous one was the simplest example. It will be solved only in 2 steps, and now in this example we have more than 2 steps. So 1, 2, 3, 4 steps are there. So in 4 steps this sum can be solved easily. Everyone understood this? Yes. Now let's move ahead with one more example with some higher level of difficulty. So 2x by 3 plus 1 equal to 7x upon 15 plus 3. This is again one more linear equation in one variable, in which again the variable is on both sides. So on the left side we have 2x upon 3 is one variable term, and to the right side we have 7x upon 15, one more variable term to the right side. So now again we need to take both of these two variable terms to the left side. So transposing this 7x upon 15 to the left side, so again the sign will change. So 2x minus 3 minus 7x upon 15. Okay, so transposing this 7x by 15 to the left side. In the same step, I have transposed this 1, the constant term, to the left side to the right side. So the sign again of this 1 will change. So this plus 1 will become minus 1 when it come to the right side. So this become 3 minus 1, and to the left side we have taken both the terms of variable to the left side with change in sign of that term which is to be transposed. So 7x upon 15 as transposed, so taken to the left it will become minus 7x upon 15. So now here it is the difference of two rational functions, rational terms, okay, with the rational coefficients. So to simplify it, one of the easiest way to make the denominators of these two equal. So here the higher denominator is 15 and 3 is in the multiple of 15. This 15 is in the multiple of 3. So we need to make the denominator equal. So that can be done by multiplying this 3 by 5. So multiply in mathematics we can't multiply only. So whenever we want to do any additional operation, we need to do that in equal and opposite way. That is, if we are multiplying, we need to divide by the same term. So here we have multiplied this 5 to the denominator. So in case of rational number, we need to multiply it to the numerator also, right? So this 2x by 3 is multiplied and divided by 5, or the numerator as well as denominator both are multiplied by the same number, so that this rational term 2x by 3 will change to this, that is 10x upon 15 minus 7x upon 15. So here the new rational number or rational term we are having with the denominator same as this 15, that is the second rational term, okay, with the denominator 15. So now the denominators of both of these two rational terms are same, that is 15. So keeping this 15 as it is, we can just add or subtract whatever the operation is here, either addition or subtraction. If it is addition, we just add the numerator. If it is subtraction, we just subtract the numerator. So 10x minus 7x upon 15. So 10 minus 7, again we need to take the difference of the coefficients of the terms of x. So 10 minus 7 is 3, so it is 3x upon 15. So 3x upon 15, we can simplify again 3 and 15. It is 3 ones are and 3 5s are. So it will be, we have 1 by 5x equal to 2. So taken again 5 to the right side, or to remove this 5 from left side to the right side, we need to again multiply by the same number. That is, to cancel 5, we need to multiply 5 on both sides, so that this 5 from left side will get cancelled. It makes this variable x free from the coefficient other than 1. So here we have x, and to the right side it will become 2 into 5 equal to 10. So we can say that x equal to 10 is the required solution for the given linear equation in one variable having the variable on both sides. Hope everyone understood this. Clear? Let's move ahead with some more example. Let's see the sum number 4. The fourth type of example on this part is like this: 3m minus 5m equal to minus 8 upon 5. Sorry. So again the same steps we need to apply here. We need to take all the terms of m. The variable is m here, so m is a variable, so we need to collect all the terms of m together, that is to the left side. So here 5m is to the right side, I need to take it to the right left side, means we need to transpose this 5m from right to left, right? So 3m, this 5m will become minus 5m. If you transpose it to the left, the sign will change, so 5m will become minus 5. And to the right side, this constant term will remain same. The constant term is minus 8 by 5, so it will remain as it is. So again, taking the difference of 3m and 5m is nothing but taking the difference of the coefficients. So it is 3 and 5. So 3 minus 5 will give us minus 2. So minus 2m equal to minus 8 by 5. So again, to remove this minus 2, which is in multiple of the variable m, we need to divide by minus 2 on both sides, right? So dividing by minus 2 on both sides, it gives us, so dividing by minus 2 to the left side, this minus 2 will get cancelled. You left with only m to the left side, and to the right side minus 8 by 5 is divided by minus 2, means it is multiplied by its reciprocal, that is 1 by minus 2. So since both are negative, minus 8 by 5 and this is 1 by minus 2, the minus negative sign, the product of two opposite two same sign will become positive. So minus and this minus will get cancelled, it will make the product positive. So here we simplify this 8 and 2, so 2 4s are 8, so that we have the value of m is equal to 4 upon 5, which is nothing but again the solution of a linear equation in one variable having the variable on both sides. Clear? Yes. So these are some examples, different type of examples which may ask in the exam to solve the linear equation having one variable and the variable term on both sides. The variables are on both sides, but it is the linear equation in one variable only. Clear? Yes. So now we are going to solve some example, the word example, or we can say these are the application based examples, or we say the some applications of this type of linear equation. So in case of word example, the very important part is to get a linear equation from the given condition in the word example. Let us see how to get a linear equation from the given word example. Let us see. So let's see the first example given. The first example given is Amar thinks of number. So Amar is thinking of a number and subtracts 5 by 2 from it. Okay, and he multiplies the result by 8, means whatever the difference comes by subtracting that number by 5 by 2 from it, result, he multiplies that result, that difference by 8. The result now obtained, that is by multiplying by 8, the result now obtained is 3 times the same number he thought of, means the original number, whatever the original number he thought, the resulting number will be 3 times the same number. So here the question is, what is that number? Means we need to find this number, which number he thought of. So in such case we consider let x be. So we need a variable in the linear equation, right? So we need a variable. So in general we consider a variable as x. Okay, as we know various examples, the variable will be x, right? So let us consider x, let x be the required number. So now apply the conditions here in the examples given. So what are the conditions given? Amar thinks of a number and subtract 5 by 2 from it. So let's subtract 5 by 2 from it. So x minus 5 by 2, and he multiplies the result by 8. So whatever this difference we have, it is multiplied by 8, means we have the left side or the number is 8 times x minus 5 by 2. And what it says again in the example, the result means the new number, the result now obtained. So whatever this product and this difference, after getting the multiplication and simplifying, whatever the number we will have, it will be the thrice or 3 times the same number he thought of. Whatever the number he thought, he thought a number of x. So that required number or the resulting number will be 3 times the original number. So it is 3 times x. So that is by using the condition given in the example. So this step is very important, because this will give us a linear equation in one variable, and that too having the variable on both sides. Clear? So now after getting this, just we need to simplify and try to get a linear equation in one variable. So here 8 times x minus 5 by 2 equal to 3x. So multiply this 8 inside the bracket to both of these two terms. 8 into x is 8x. 8 into 5 by 2. So minus 8 into 5 by 2. This 2 and 8 can be simplified, so that it will become minus 4 into 5. So 4 5 are 20. So the equation we have is this: 8x minus 20 equal to 3x. So it's a simply or a general linear equation in one variable having the variable on both sides, as we have seen, as we have solved such example just before this. Okay, so now let's solve this. It's a very simple example. Just we need to convert this 3x, or we take this 3x to this left side and take the transposition or transpose this minus 20 to the right side. Means we collect the variable terms together and constant term to the other side. So let's see how it can be solved and what will be its solution. So here we have, so transposing 3x from RHS to LHS and transposing this 20 which was to the left with minus sign, it comes to the right side with positive sign. So 8x minus 3x will be equal to 20. So how much is 8x minus 3x? It can be done again by taking the difference of the coefficients. So 8 minus 3. 8 minus 3 is 5. There. So we have 5x equal to 20. So since the coefficient of x is other than 1, we need to make it 1 by dividing by the same number. So dividing this 5x by 5 and 20 by 5, we need to divide a number on both sides. So 5x upon 5 equal to 20 upon 5. So this 5 from left side will get cancelled, and this 5 will simplify this 20. So 5 4s are 20. So it gives us x equal to 4. It is the solution of the linear equation we have from the given condition in the word example. But what is x we have considered? We have considered x as the required number that Amar think of. So here the required number, we can say that the required number that Amar think of is nothing but a number. Number is 4 that Amar think initially, right? So student, in this way we can solve such word examples. Even if the example is looking so much larger, somewhat complicated, don't get confused. So just try to solve it very calmly. First read one by one the sentences given in the example and try to solve it step by step. You will get the answer for such type of examples, right? So now let's see few more examples. Let's see one more example here. The second one example. The sum is like this. Sum of two-digit number is 9. Okay. When we interchange the digits, it is found that the resulting new number is greater than the original number by 27. Okay. The sum of two-digit number is 9. When we interchange the digits, it is found that the resulting new number is greater than original number by 27. So what is the two-digit number? So just try to understand. Try to read the statements given in the example and try to get an expression in terms of one variable. So here, since the number is a two-digit number, I consider x and y as two numbers here. So let x and y be the two digits of a two-digit number. So out of which one will be the ones place, other will be the tens place, right? So as we are given the sum of these two digits is 9, so I can write this x plus y is equal to 9. So why this condition is given? This condition is given to convert that y in terms of x or x in terms of y, because we need a linear equation in only one variable, not in two variables, right? So even if we are consider two variables x and y as the two digit of a given number, the one condition is given to convert the second variable in terms of the first variable only, right? So by using this condition, I can convert the second variable in terms of the first one, that is in terms of x. So I can write y equal to 9 minus x, or I can say that x, the first digit is x and second digit is 9 minus x. Clear? So now it is clear. Sorry. So y equal to 9 minus x is a second digit, one more digit, and first digit is x. So now let x is one's digit and y means 9 minus x is the 10th digit of a two-digit number. Okay. So using these two, I can write the required number. The required number when the two digits are known of a given number can be obtained using this one, that is x plus 10y. Why I have written multiply this y by 10? Because y is a tens place digit. So tens place digit, to get a number we need to multiply tens place digit by 10, and units place or units place can be, or ones place can be written as it is. So x and the sum of these two will give us the required two-digit number. So x plus 10y will be equal to, if you open the or we replace that y in terms of x, so it will become x plus 10 times 9 minus x. Okay, because our y in terms of x is 9 minus x. So this is our original number, students. Okay, we need to keep it in mind. So we'll use it afterwards to get the answer. So here let's move ahead. So when we interchange the digit, so here we have the number as x plus 10 times 9 minus x, considering x as a ones place digit and y as a tens place digit. So the number we have is x plus 10 times 9 minus x. Now if we interchange digit, means if we make x as a tens place digit and y as a units place digit or ones place digit, what will be the number we obtain? So when we interchange the digit, that is x will be tens place digit and 9 minus x is the ones place digit. So our new number we will obtain will be this one. That is 9 minus x is 1's place and x is 10's place. So 10's place should be multiplied by 10. So 9 minus x plus 10 times x will be the new number. Now you are given the relation between them in the given example, in the word example. What is the relation given? The relation is given that the new number obtained means this number, the equation we have in the second one. If I denote this as a 1, this is this second equation, and this will be the first equation we have, right? The expression we have, this is 1. So the new number means the equation number 2 is greater than the original number by 27. Original number is this, equation 1, expression 1. Okay, so the new number, equation 2, is greater than this original number by 27. Means equation 2 is equal to equation 1 plus 27. So greater by 27 means we need to add that number. So we need to add 27. So our equation will be like this. By using the condition, we have the new number obtained is this, that is this one, equation number 2, that is 9 minus x plus 10x is equal to 27 more, that is greater by 27 to the original number. The original number is nothing but the expression 1, that is x plus 10 times 9 minus x. Okay, so this is a very important step in this example. So once we got this, the remaining part is very easy. So just go and simplify, you will get the value of x, then resubstituting, you will get the value of the tens place digit, that is 9 minus x, and you will get the required 2-digit number. So here we simplify 9 minus x plus 10x, remove the bracket. Here also we do the same, x plus 10 times 9 is 90, 10 times x is 10x plus 27, just remove the bracket. And now if you see, here we have minus x plus 10x will become 9x. To the right side we have again two terms of x, so x minus 10x will become minus 9x. So taking the sum of the constants, it is 90 plus 27 is 117, and okay. So now here we have an equation in which the variable is on both sides again. Okay, here to the left side I have 9x, to the right side I have minus 9x. So I need to take both of them to one side only, that is to the left side. I take the right side term to the left side. So left side 9x remain as it is, minus 9x is taken to the left side. So transposing this minus 9x to the left side will make it plus 9x, and transposing this 9 from left to right, again the sign will change, will become minus 9. Okay, so 117 minus 9. So 117 minus 9 will give us 108, and 9x plus 9x means adding the coefficient 9 plus 9 will become 18x. So 18x equal to 108, or x gives us 108 upon 18, or 108 upon 18 means if we divide it by 18, so it will give us 6, or if we try by 9, 9 2s are 18, 9 1s are 9 2s are 18, again it is 2 6 are 12. Okay, so we have the value of x as 6. But what is x we have considered? We have considered x as the ones place digit of a 2-digit number. So we got ones place digit, and then tens place digit we have considered as y, which was given in terms of x as 9 minus x. So substituting the value of x here, it will be 9 minus 6, that is 3 only. Okay, 9 minus x is 3. So we got the units place, we got the tens place. So what will be the number we have? We have the original 2-digit number as x plus 10 times y, that is x plus 10 times 9 minus x. So it is 6 plus 10 times 3, that is 30. 6 plus 30 will be 36. So that gives us the required 2-digit number of a given example. So we got a 2-digit number satisfying the given conditions in the given word example. So isn't it so interesting, students, right? So this type of example may also ask in the exam. Okay, so let's try. You can try more examples of this type. We have solved 2 type of example today. One the example in which the equations are given directly having the variable on both sides. That is a linear equation having variable on both sides. And the second example we have solved the example, that is we say the applications of this type of example, that is linear equation having two variable on both sides, not two variable, the same variable, but it is on both sides, right? So you need to do the practice, we need to solve more example of these types. Okay, so I have given here more example for practice. I will just give the hint of this example, you can try it afterwards. So as the example is, a man's age is 3 times his son's age. 10 years ago he was 5 times his son's age. Find their present ages. So here the relation between the ages of Aman and his son is given, and Aman's age is compared with the age of his son. So whenever such comparison is done, the term with which the comparison done, that should be considered as x. So here the Aman's age is compared with the age of his son, so I can consider the son's age as x years, and then try to write the Aman's age or his father's age in terms of the age of his son. That is, Aman's age will be, as it is given, this 3 times his son, so it is 3 times x. So simple. Okay, now one more condition is given, that 10 years ago. So this word is very important in the example. If you understood this, the remaining part can be solved very easily. So 10 years ago, 10 years hence, after 10 years, before 10 years. So these words will play very important role to get the correct answer. So ago means it is previous, means we need to subtract that number from the present ages. So we can say, since 10 years ago, ago means we need to subtract. So that son age will become, so it is x presently, so before 10 years it will become obviously x minus 10, so 10 will be subtracted from his present age. So his father's age, Aman's age, will become again minus 10 from this, so it is 3x minus 10, because 3x is his present age, so 3x minus 10 years, right? So now the condition is given, a relation is given between these two ages. What is the condition given? He was, so he was means 10 years ago he was 5 times his son's age. So these are the ages before 10 years, and Aman's age or his father's age 5 times his son's age. So it's so simple, just multiply this by 5 and equate these two. So 3x minus 10 equal to 5 times x minus 10. So 3x minus 10 equal to 5x minus 50, right? So solve it and you will get the required answer for this. I will leave this remaining part for you as a homework. Okay, so now I have a few more examples for you for as a homework. So you can just note down and take a screenshot, and you can try to solve these more examples as homework. Okay, so here we have few more examples. So we'll meet again in the next video with new part of this topic, next part of this topic. Till then, thank you.